open.
Yeah, sure, Rohit.
Yeah, the good evening, teams. Welcome you again with the second day of the introduction to IPG Carmaker. Yeah, we are going to present you few of the glimpse on maneuvers, IPG movie, controls, graphs, and many more things today. So we are having Mr. Rohit with us, who will be starting with the seminar. Over to you, Rohit. Yeah.
Yeah, thank you, Rhythm. Hi, team. Very good evening. So let's start with a few introduction from IPG kinematics. So there are the two ways to open IPG kinematics app or the IPG kinematics GUI. Either you can go to vehicle dataset, then you can go to kinematics from the suspension. So here you can select the either linear 2-degree or SKC file. So it will show an option called IPG kinematics. If you click here, IPG kinematics GUI will open. So there is one more method. You can click on the file, then you can get into the IPG kinematics GUI. So what I suggest every time is please go from car, vehicle dataset, then select, and here you can choose your SKC file for either the front for the both axis, front and rear axis. So now I am going with the front axis. So there is a theory behind IPG kinematics. So IPG kinematics is a program system designed to simulate vehicle axis on the text track kinematic test bench. So where it is used to calculate the kinematics, steering kinematics, and electrokinematics. So this is the small theory behind IPG kinematics. So from this is the IPG kinematic menu. So here we have options called files, edit, analysis, and the help. The below one are the shortcuts where you can directly get all these things here. Maybe if you click on this, you'll directly see the file options, which are the models available, the suspension models available. So this option is directly used to select the folder from which project folder you are choosing the SKC file or where you want to save the SKC file. So this option is used to save the SKC file, and this basically used to print your SKC file, whatever you will create. So as of now, I haven't created anything, so it is empty. So this option is called edit simulation option. We'll explore this bit later. So what are the options here available in the analysis bar? Those are here as a shortcuts. The all are available. So always this icon shows about the information about IPG kinematics, the which version, and the company logo. So if you click on this, and you'll exit from the IPG kinematics, and everything will be closed. So we'll do it by manually rather than we'll create the sketch file manually rather than going with the shortcuts. So in the analysis table, you can filter out whatever the data you or the values you want to see. So basically, when you generate the sketch file, you will be all those logs are printed here in this white background, and this is sort of it will act as a filter if you select one of the options. So values will show up based on these calculations. So one more thing, this stop menu or the bottom menu, it will be used for minimizing and maximizing the this GUI. So in the BAJA events, we are using the double wishbone suspension model. So first click on the new option, then select the wishbone model. So more information about the available available suspension models for front and rear axis, you can find it in our IPG kinematics guide. So I have selected the double wishbone. So if you see it here, this shows about the standard templates path. In the IPG kinematics, we have some standard templates for all the suspension models. So first we need to select from the file new, and we need to select the double wishbone model. So let's go to the simulation control from the edit option. So here we have a few things. For this IPG kinematic, it shows the which version of IPG kinematics we are using. And for the double wishbone suspension model, this is the name. It's a default name from the IPG it's given. So here you can add some comment. Maybe you can change to my model or something you prefer. So let's say let's get into the option called force on and force off in the kinematics. So what actually it means is, in the kinematics we can do three tests. So like the parallel kinematics or steering kinematics, uh, it's based on your front and rear axle. So when so if you select the force off option, it means like it will calculate your inertial forces or mass of the suspension components. So here in the storage tables, I'll just show you. So if you click on the log on option or log option, you can see it all the data here printed over, or what are the calculation we have done, it's all printed over here. So now if you click on this option, you'll see the parallel kinematics, or you can see the values for reciprocal kinematics, whatever it is calculated. Those are visible on here. For the storage results, always you have to select the Carmaker interface 1 or 2. So because the Carmaker supports the SKC file, so you can select this option. So let's get into the options called kinematics. So when the parallel kinematics is on, it means your both rear and both rear and front wheels are both your rear wheels moved up and down at the same time. So it is always based on your axle. So as I am doing it for the front axle. So in the parallel kinematics, if I keep it on, so the it will calculate when the both rear wheels moves up and down. So in the compression, it is measured in mm. So the maximum value is 40. It is nothing but the wheel travel from the initial in the design position, how much it moves up and down. So the minimum value is the right side rotation, the right side movement, and maximum value is the left side movement. So if you give the step size as 5, for every 5 movement, all these are calculated. So if you see it here in the reciprocal kinematics, so the values every 5 movements, you can see the wheel torque, vertiage, and toll and camber, total roll, all are calculated in the interval of 5 5 5 mm. So you can keep the steering kinematics on or off based on your axis. So now I am using the front axle. So I'm keeping it on position on one. So when you turn it on option one, the steering kinematics will be calculated only on the starting position. In the sense, when the wheels are in the design position, it will be moved from right to left variation. So it will be calculated. When you keep this option as the 2, then the steering input along with the wheel travel is calculated. So as of now, I'm keeping on. So now we are not using the reciprocal condition according to the Baha guidelines. So I'm keeping it on. So here the distance of steering to rack is nothing but from left side to the right side movement. You can like uh, divide into 40. So maximum is minus 40, and and the minimum is 40 40 40. So if suppose if the suppose if the wheel travel is the steering rack travel is around 80 mm, so we can divide it like 40 and right side 40 and the left side 40, and again the step size indicates the same. So every 10 meters of 10 millimeters of movement it will be calculated. So next we'll explore the option called compliance. So when vehicle is moving, there will be a lot of force acting on the suspension, which causes the deformation or depletion, or the like torque steerings. Or so as of now, we'll keep the lateral force off. So you can keep the lateral force from 0 to 100% in between how much it is affecting. So as of now, I'm keeping all these forces off in the compliance. So in the mixed force, I'm not using it, so I'm keeping all the mixed force off. So first you have to enter these parameters. And next we'll go to the vehicle data generation. So here in the general settings, you can choose the axis based on if you're creating SKC file for the front axle, you can select the front axle, or if you are doing it for the rear axle, you can select the rear option here. So as of now, I'm doing for front axle, I'm selecting the front option. So brake force percentage, it is so brake force percentage is nothing but when the vehicle is braking, at that time axle should be in between 0 to 100%. So for the detailed information, you can refer to our page number 23 from the IPG kinematics guide. So basically this is used to calculate the anti-dive, how much the vehicle nose goes down during the braking. So if you're based on your rear wheel driving or the front wheel driving, you can enter the brake force. As of now, I'm keeping it as 50. So next option is the driving torque. So based again, it is also based on your axle. So I'm using front axle. I'm generating SKC for front axle. So based on how much torque, steering torque, it will be delivered to the front axle. So I'm just keeping around 50%. So if you know the ratios of your steering torque, and you can adjust over here. So again, here we have something called tire rate. You can easily find it out. Just a second. So as of you know, yesterday you have learned about vehicle data set and vehicle modeling, right? So here eh, you can easily find out the vehicle tire rate. So if you go to tire, so you can see it here, right? Vertical radial stiffness, Newton per meter. So again, you have to convert that value into Newton per mm. So you can enter this value over here. So next parameters is vehicle height, vehicle center of gravity. Here it's default coming as 425 mm, but this also we can find it out from your vehicle parameters. If you go to vehicle assembly, and you can see here the value. This value is Z value. Again, you can write it. You have to convert this from meters to millimeter, and you can enter it over here. So these are all the necessary parameters you have to enter in general setting. Next, we'll get into the springing. So as of now, we are keeping the chassis subframe as the constant. So we are turning it off. If you are mounting your steering gearbox to the rear wheels, you can just select this elastic mounting option on and off based on your usage. So now let's get into the springing options. So spring is nothing but your shock absorber where your fixings to known for like upper or the lower, you can choose it over here. So in the just a second, I will just show you. So basically it's this parameter you are entering whether you are uh, mounting your spring in the upper position or the lower position. So I'm just selecting the lower wishbone option. So if you are putting a stabilizer bar, you can enter the bar parameters, or if you are not using any stabilizer bar, you can give it as none option, and you can keep it as none. And if you don't have the transition, you can keep that is also a none option. So in the sense, like if you don't have any transition parameters, you can just keep this pull and push rod as none option. So then you don't need to enter any of these values. So let's be used as it is options. So we'll keep it as a 1 kg because this software uses the connected calculation. So we'll keep this mass as 1 kg to better understand the geometry of how to enter this geometry values. Also in the access system, you have to select DIN 700. You can refer our IPG kinematics guide over here. So here you can see all the bodies and points. There are 19 node points. You have to select this from your CAD model, your designed vehicle. So for each parameters and each points, so definitions has been written over here. You can consider the FR1 to add the values to here. Then save the file. So I am using my folder called SKC, using my project folder called SKC, and I'm saving this SKC file inside it, data under the chassis. So either you can keep it as SKC king or the default option, and you can save it. You can give a start. So once simulation finishes, all these values are calculated and it will be stored inside this file. This is my project, CM project, Carmaker project. Inside the data, there we have option called chassis. Inside this, you can see the new suspension file, the sketch file I have created. It saved it here. So also this is an ERG file. You can analyze this inside the IPG graph. So if you select this geometrical control from the analysis, so it will show us what are the points you have to enter, and you can see these points. So it will give you the namings and what are the XYZ coordinates you have to select. So this is from the YZ view, and this is from the side view, and this is from the top view. So there is one more option called graphical analysis, where you can load your .erg file. So you can load your .erg file into there, and you can do the graphical analysis. So once after generating your the SKC file, you can close the GUI. It's fine sometimes. So once you successfully generated the SKC file, you have to go get back to your vehicle parameters from the vehicle data set. You can go to the suspension and SKC file. Here you can select your by clicking the model, add model option. You can select the saved SKC file from. So entering the random values, that file's got showing some error. So I'm selecting the one of the SKC file which I have generated earlier. So after selecting the SKC file, please remember to save the changes whatever you have made. And now you can run the simulation. So actually, this test run, I have entered some manuals. So according to those manuals, this is behaving, and can see we have seen that I have selected the generated SKC file, and I'm using that file. So this is all about IPG kinematics from the my side. So let's jump to the manuals and IPG control. So this is the IPG Carmaker GUI. If you go here to create a new test run, you can just type your Carmaker version from your. and select your project folder and select your vehicle from here. To write the manuals, either you can go from click on the parameters and directly get into the section called manual, or else you can get into the manual section press by selecting this option here as the manuals. So it will open the scenario editor. This is about our static scenarios where you are building the roads and adding the 3D objects and other parameters over here. So after creating the road, you need to generate the routes, and you have to place your ego vehicle at the starting point of the road, or at particular point you can place your ego vehicle. So manual is nothing but which is used to control your ego vehicle behavior or the ego vehicle speed and other actions. So there are two options. One is longitudinal dynamics and one more is lateral dynamics. In the longitudinal dynamics, you have the control for uh, so here few options are there. If you give not specified, your vehicle doesn't move at all and it will be stay at constant position. If you select the IPG driver, you can define some speed over here based on your driver characteristics. Your vehicle will behave like if I am using the standard driver and defined as a 40 based on the road or the static desired course, so driver will drive the vehicle. Again, you can change the driver parameters to different based on the conditions. Maybe you can use aggressive driver or defensive driver. So if you use aggressive driver, he will behave as it is, like he will go very fast and he will ignore the other traffic constraints. So if you're using the defensive driver, he will drive the vehicle slowly and he will behave as a defensive person. And if you use the car normal, so here everything is set. So you can set some speed parameters like longitudinal parameters, you can use 50 or 40. So also you can set few parameters like throttle smoothing and how you can drive and the speed offsets and so all you can control over here. So I am selecting this normal OSC. I'm just coming back to the car dot normal. Again, if you want to create some particular driver template, you can use this option called add driver, and you can select your driver presets. So I'm importing it from car aggressive. So I have created my own driver template, and I'm selecting the driver over here, and I have given a speed as 40. So this is all about IPG driver and its speed. So if you give drive backwards, your vehicle will start moving from the reverse position. Just show you over here. Just a second, I'm opening movie index. So as you have seen, I have entered the drive backwards maneuver. So and I have set the speed as 20, and at the speed 20 he's moving backwards. You can observe over here. After some of upside zero dynamic error called vehicle leaves the road. So other options. So give stop vehicle at a particular distance. If suppose if I have a distance 20 meter or 30 meter, so the distance during the your so here specify the time. So if you don't want to specify the time, you can specify the so, and it will in the lateral dynamics. Audible guys. Somebody can please
You're audible. Just once. Rohit, can you just turn on your mic and like if you restart your mic?
on. Let me restart one.
Yeah. Um.
Am I audible? Am I clear or
We can resume your presentation. Yeah.
so from was not let are not able to what multiple options. Uh, Dynamics. The one more option is tracking. So
Yeah. Rohit, sorry to hold you. You are not clearly audible. Can you just repeat it once?
yeah, okay. So now am I audible or like still the voice is low or
Yeah, it is perfect now. Yeah. Thank you.
okay. So I will continue from here onwards. So I will open IPG movie to demonstrate you guys. So different parameters. So I hope my screen is completely visible, right?
Yeah, Rohit, you can go ahead. Thank you.
So in the longitudinal dynamics, we have other options. We'll explore them, try to try to explore most of the options. So there is one more option called speed transition or the so if it is like linear transition means it will go from 0 to 50 very linear way, or if you give sine it will varies the rate from like 0 to 50, it will reach in different timings. So again we have in the speed transition we have called step option. So step by step, like from 0 to 10, 10 to 20, like that it will increase to till 50, the targeted level whatever we have mentioned. So there is one more option called speed profile or speed control. So in the speed control, if you limit your vehicle speed to the 50, so if your vehicle never reaches more than 50, so it will be very stable and it will be only with the it will only maintain the speed 50, and you can mention the deviations and also you can select the gear shifting. So you can observe till end of the simulation, our vehicle will meet run in only speed at 50 kilometers. It won't cross 50 or it won't come below 50. So this is the uses of. So in the manual, there is one more option called manual pedals and gears. So directly you can give the values for the clutch, brake and gear. If you select -1 over here, your vehicle start moving in the reverse. Or if you select, you can select your gear number, maybe 1 or 2, or you can give the. So as of now, I have not selected anything for the throttle. So my vehicle is in standstill. It's not moving. So rest of the things you can explore, guys. So in IPG driver plus user driver, it needs a few parameter compilation, and you have to enter the few values for this. So let's get into the lateral dynamics. So if you use IPG driver option, so he will follow the static desired course, and there is one more option, and also you can select the lane offset, maybe 5 meters or 10 meters. So if you want to, if you give 5 or 10 meters, so he will start from right side, the most high from the road. So you can see I have given values to, and the vehicle is moving complete to the half of the road. So I have given values to lane offset. So it's far from its driving lane, 2 meter away from the driving lane. So there is one more option called sign option. So if you give values to here, he will move. The vehicle will follow the pattern like this, a sine wave. So you can use that. Also, there is other options called lane change. So here you can mention which lane it has to change, at what offset. It's a lateral offset. You have to mention maybe 4 or 5. So I can just mention. I haven't generated one more lane. I will generate it. So here you can see at after some distance the lane has been changed. So I have given the lateral offset value is more, so the vehicle is moving very far from the lane. So all this will throw us an error. So this is about the manuals. So let me open different test run and I will introduce you about the manual commands and real-time expressions. So in the manuals, there are two options. Okay, here you can define an end condition. So here I have defined like when car.v car velocity is lesser than 15. So this maneuver will end and it will jump to the next maneuver. So to define user accessible quantities, your own accessible quantities, you need to follow this syntax eval qu 4 dots v max is equals to 0, and I am also logging the vmax value. So this is the command which I have used here from the in beginning of this manual. Whatever the vmax value will be there, it is logged into our session log. So one more noticeable thing is, so when you are defining your custom UAQs or your own user accessible quantities, either it has to include two of the to see some values in that, you have to include some Carmaker user accessible quantities. So this car.v is from the Carmaker user accessible quantities. I have used it over here, and Vmax value was 0 initially when starting the maneuver. Then it will store the values of V0 and car.v, and it will log the values over here over the session log. So this is the commands to write a log function. Also you can see, also you can refer our IPG user guide to explore more options. You can see some more examples over here. So if you go over here, so if you get into our user guide and if you go to the section called mini maneuver command language, you can see how to write the commands and basic syntax over here to control your vehicles. So to understand or so each UAQs, the Carmaker UAQs has its own meaning, and those are the vehicle parameters. You can see it over here in the our reference manual. So if you get into the reference manual and if you search for user accessible quantities based on every vehicle parameters or the Carmaker, based on like and other either from the environment or the driving manuals, you can see all the quantities whatever mentioned as a dm dot brake park or dm dot gas. So these quantities are called as DVA quantities. DVA quantity is nothing but when the simulation is going on, when you are running your simulation, at that time you if you enter some values or if you give some values, it will override the simulation. So I can just show you one example over here by directly entering the value. So let me just split my screen. So if you click on the application and you can see the direct variable access is there. So here you can go and browse. I'm selecting dm.break. So one more easiest way to identify the DVAs are, so if you go and search over here in the DVA bar, so whatever appearing in the blue color, these are the DVA quantities. So in the sense you can manipulate this values while running the simulation. So you can select and give it like this. And there is other ways to define a DVAs. I will show that also. So if you select -1 for the whole simulation, this value will be 1. So I am just trying to add the trying to vary the DVA dot break. So if I set the value as 1 and break will be applied, so you can see that while simulation is running only, the whole break value is 1. So it is jumped from manure 0 to manure 1. Also you can see the log values, the session log. I'll show you how you can give the DVA values, or how to use DVA using the manures, mini manure commands, or the real-time expressions. So either you can define it in the manure 0 or manure 1. You con edit view like there is a syntax for defining the DVA entities or using the act the DVA. WR means DVA write or release. So the quantity name the quantity which is your it is not quantities like break sodium dot. So quantity so mode means I upload or cycles are the number uh, like the quantity, and it has to be is if you select and that's uh, day and selected site. And so at time this will be overwritten if so it will overwritten by 2. So one value to but can give it for divide one can specify.
Rohit, sorry to cut you. You
Yeah.
are not clearly audible again. Can you just restart your mic once, like just turn it off and on once I start? Mhm. And if, mhm, yeah.
So it's very strange today I'm seeing this error like this issue.
Mhm. Uh, yeah, it is clear now. You can start with the same.
Okay, I think whatever explained over here, it was missed right in the last time.
Yeah, the last thing you had delivered was missed. Uh, okay.
Okay, from here I have to just I can just
You
be
need to
quick and
present your
yeah, yeah.
screen. It has been stopped.
So from this line, so audible or it's not audible? No. Hello. Hello. So this is syntax for the DVA. I'm just putting as I'm commenting out. So if I keep this as it is, so it will throw an error because so either you can use real-time expression or the miniman your commands to edit the DVA quantities. So I am using this. So at when the time is greater than or equals to 15 second, that time steering angle will be set as 100. It will be set as 0.34 radians for 1000 simulation cycles. So I have added this command over here in the commands. So we can see all these values. So we can map the simulation data or we can plot the data in the IPG control. So you can go to the files and select IPG control. So whatever the parameters you want to map, you want to plot, you can select it over from here by clicking on the add quantities. So as of now, I'm using car.a of x. You can select the required values and all these meanings. You can find it out over our IPG user reference manual under the sections user accessible quantities. So you can select the quantities which you wanted to plot and you can start the simulation. So all this value will be modeled, value will be plotted. Yes, suggestion.
No worries. You can continue. Uh,
Okay, there's somebody raised the hand. So this was
uh,
about IPG control, how you can plot the graph. So I will show you how to export this plotted data into the different formats like either CSV formats or the Excel data. You can right click on the this background and you can select the option export to the file So here it will shows the file format. You can select the different formats, or you can select directly the Excel or CSV file. I'm using .csv file. So it will it will also give you the option where you can save these files. So usually it is recommended to save all the files inside the sim output folder. So you can name your file as, so it will be automatically saved by .csv file, and if you click on save, so your file will be saved, and you can open these files using the, you can go to file explorer and you can navigate to your project folder, and then you can select the, so here you can see this file saved in CSV format, and you can open it over here. So all the values whatever I have selected along with the time has been come, you can see it here. And thank you team, that's it from my side. So if you have any doubts, we'll discuss that in QA session.
Yeah, Rohit. Thank you so much for delivering this session. I hope teams will able to configure their IPG kinematics files as well, and able to load their SKC files in their vehicle as per their requirements. And then after, they will also be able to understand the DVS which you have explained. With the help of IPG control, they will be able to plot few graphs and perform many analysis which are necessary for them and to optimize the vehicle. Yeah. Coming to the next part, that is a tire generation. Manoj will take up with the tire generation. That is, if a team is having a particular tire data set which they wanted to create, then it will be possible with the help of kinematics and being explained by Manoj. Manoj, please hand over to you.
Yeah, hi. Hi guys. My voice is audible, right?
Yes, Manoj.
Okay. Good evening, guys. So we'll see how we'll select like the existing models in Carmaker for our tires, and then we'll see like how to generate like a completely new set of parameters for your ATVs. So mostly uh, everyone will be using like this kind of tires from BKT or whatever manufacturer you're getting it from, 22s, 10, 10, and this kind of nomenclature. But whatever we have in IPG car maker is this nomenclature, like 195, 65, 15, those kind of things. So we'll go step by step on how to like configure for it for our tires. So first, you can go here, go to parameters, you can click car, and then either you can select one tire for all the axles like front and rear. If you are using like the same tire, same diameter tires for front and both, or else you can click on this separate panels and then select for your tires like front if you are using 22-inch, and then for rear if you are using 23-inch tires, you can select accordingly, and then we'll see like how to generate tire for our specific needs. So let me go here. So once you click this, either you can long press it and then go directly to edit, so that you can edit the selected tires here, or else you can select this. So a window will pop here. After that, you can select any one of the tires from here, or you can go select one tire from here, right? And then in file, you have to go for a generator. So as there is no like pre-built model for our BAJA ATV vehicle, we'll click generator here. So from this generator, we'll go and select one of these tires. So tire size, radius, keep this, and either you can generate, you can go to this tire data generator, and then let me open it. After this is done, let me clear with the generation first. Okay, so once this is done, you are in this page, right? So you can input the same values for this. So if you don't find like the same values, whichever is calculated for your vehicle. So this is the calculated tire dimensions for this 22 10 10 tire. So if you don't find it, you can select anything like which is nearby. So let me select these things. And then you can fix the inflation pressure. And then another important point is you should not select the coefficient of friction anything other than 1. So it should be equal to 1 because the coefficient of friction will be defined in the road file whichever you're going to drive on. So if you are giving the anything less than 1, this coefficient of friction will be taken into account like when you are going in different parts of the track. So let me consider this is my track. So I'll be giving coefficient of friction as 1 for this tire, and then let me consider like this part of the track has some kind of muddy pool or something. This will have a different coefficient of friction. So your tire should be having like coefficient of friction as 1 throughout the tracks, and then depending on the section of the track, it will be considered accordingly. So once you guys select all these things, coefficient of stiffness to let be 1, and then you guys need to click here as keep TiDX file. So once this is done, you'll have a file generator in your project folder. So this is my name, TiDataset. dataset. So once I get this, I'll go to my project folder. So I guess you guys are well aware of where the project folder is. So once you create your project folder, I have my project folder CM projects. I'll go in this, and then in data, go to tire and go to examples. So here I have like previously I've generated a bit some of tires. So I'll just see what is the name. So this is the tire I've generated. RT255 65 R15. Okay. So I'll have totally 3 files. So one file is TDX, one is a bin file, and one is the info file. So this will be used for your car. So once you get this TDX file, but this file is not according to your car's parameter. So once just take this TDX file and then paste it here, and then just go inside. If you open the TDX file alone, you'll see this all this data. So here you can edit your tires value. So if my width is my tire width is 254, I'll put 254 here, and my aspect ratio is 60, and my rim diameter is 10 inches. This one. And then my rim width, according to your rim width, you can edit this too. And leave these values as it is, and then change the overall diameter too. So let me take my diameter as something around 560. Then kinematic roll radius is for our use purpose. Let us take the tire deformation is less, and then we'll consider it as half of the overall diameter. So it will be around 80. So in these values, so what you have to do is this we have these data for the rim diameter as 15 inches, right? So what we have to do is we have to generate like 15 and 16 for these values. So once you generate for 16 too, you will go to the project folder. You will find the 16 inches TTX file to here. So you can open that and then you'll find these values. So what you have to do is you have to interpolate or extrapolate it to your rim radius. So if I have these values, this, and if you want to go like still like a perfect tire model, you can interpolate these values too, but um, for now we'll focus on these two values. So if you can take these two values and put it, there is an Excel I've created for it, and then but you can have your own Excels too, like it is easier for interpolation. So if you put like all the three values of the different rim diameters, and then you have the target diameter, you will get the corresponding interpolated or extrapolated value for your rim diameters. So you can copy this. You can go to the TDX file, You can paste that value here and these values, and then extrapolate accordingly. And once it is done, you can save this in your as your team's name. Let me just save this now and copy this name. Delete this and rename this file. Okay, this is done. So now you have a TDX file which is tailored to your ATV and your tires. So the data in this TDX file is completely according to your data. So but this TDX file is not going to be used in Carmaker. Okay, so what we have to do is generate totally two files. Those two files are this bin file and this name file. So for this generation, we'll use this tire utility. Where you can find this tire utility is go to your installation directory, IPG, go to Carmaker, go to Win, and go to this bin directory. Here you will find this tire utility. Just copy this tire utility and paste this in your as it is. You can paste it here itself, but I pasted it in a separate folder so that it will be easier for execution. And from this uh, name, you can just type CMD. You'll have a command prompt opening up, and in here you just have to type this. This is available in the IPG user guide itself. If I'm not wrong, let me check. Okay, so yeah, this is the tire utility. If this name should be replaced with your whatever you have named your tire file as. Okay, so once this is done, just paste that command here. Wait, not this. I have this already built in, so I'll just copy this, paste this, and enter. So once this is done, you will have those two files. So if you go back to the project folder, now you can see that these two files have been created, 52, 52. So these are the new files. So now you can proceed with your Carmaker, and then you can select this tires. So we can select this tire. So this is the name file. So this both won't be used in a Carmaker. Only this info file will be used for your Carmaker. And then you can select this. So you can see like all the 4 tires are selected like in the same name. If you are going to do separately, you can just create a new folder here for front and rear, and then you can select separately from those tires. So this is clear for everyone. So if you have, you can go here and then see all the values. So this visualization means that it doesn't affect any of your parameters like in real time. It just affects whatever you are going to see in this movie. So as you can see in this, let me just run this movie once and then show you what things actually mean. As you can see, this bars, some random bars popping up, right? So these are all the forces on the tires, in the tires. So this red bar shows you like how much force is on each tire. So as you can see, like when a car is taking a corner, the load is shifting on the outside. So the outer tires has an extra load on this. So this is what it actually means. When it's braking, the load shifts through the front tire. This shows the pop up in the bar. And then these are the friction bars. So this is what these bars mean. Okay, hope this is clear. Apart from that, the scaling factors you can. So as we have created a new file completely according to your requirements, this is mostly not used. So apart from that, so tire generation is clear. You can use this tire for your vehicle and then you can use it. And one another thing is, so whatever you have selected in this parameters in tires, it will be used for your vehicle. But when you select any tire from here, this will be overridden with the previous ones. So if I'm selecting this info file in here, so this tire will be used here instead of whatever you have selected in the parameters. So make sure that once you select in the parameter, you don't have to select it here, or you are selecting the same tire here too. So let me select here too. So now the same tire is being used for my simulation. So the tire part is done. Let me jump back to the sensors. So for sensors creation, first you guys have to go to the parameters, car, and then go to sensor. Here you have to press this add sensor parameterization. So once you click that, you can go to road, click road, and in this road, you just have to rename this road file as ARM underscore RD00. It is already given in the PDF too. You can just go through it, and then you have to rename all this things accordingly in this picture. It is 00, and then it is along route reference, right? So once this is done, click file save, save to project. And once this part is done, once you are once you created this sensor in this sensors tab, go to assembly, sensor mountings, and then you can select the road sensor from here and then rename it as RD00. You can leave this position as it is, and then once it is done, you will get the sensor here. So this is the sensor. So this is the position where it is mounted. So if you once you mount the sensor, if you go back here, you will see a green label so that it shows you the sensor is mounted and then it is ready to go. So I hope it is clear for everyone. The tire generation and sensor mountings. Rhythm.
Yeah.
Yeah.
Thank you. Thank you, Manoj.
Thank
I
you.
hope the student will able to understand like how the sensors are to be mounted. Teams ensure that the sensors are important as mentioned in the guidelines. It has to be mounted on your vehicle while submitting a project folder. Uh, okay, so coming next to the routes and scenarios editor, like you have already created your vehicle model. You have learned how to maneuver your vehicle, but coming to the roads on which you are going to maneuver your vehicle can be created as per your needs. So for that we are having a tool, scenario editor. um, uh, for this scenario editor, you have to go to the parameters. Over here, you can click on the scenario routes. I have already loaded one of the example for your demonstrations, but yeah, you can build your own road file as per your requirements. Uh, in this road file editors, you are having two options. One is static objects and another is a traffic objects. So static objects are a road, some of the accessories that are traffic lights, stop signage, or turn signage. Similarly, we are also having some of the scenarios, that is a bridge, a home nearby to the road, or a tree, and some terrains as well. Okay. Uh, the, heading straight to the scenarios, like if you want to create a similar road, you can go to the road. There you need to select a road marking, and then okay, just hold on, it's a bit loading. um uh, let's create a new file. Hello, am I audible? Hello, it seems I am not audible clearly.
Yeah, yeah, Rhythm, you're audible.
Okay,
Huh.
just hold on. Okay. I will close this one so I can reach. I will start from the scratch for you. Uh, okay, so teams, we will restart this. Like for the parameters, you need to go to the scenario editor. There, you can create your own custom files. Now, you need to select a road segment. What the segment means, it is a part of road, and then once a segment is created, it can be linked through different road as well. Like there are two segments, and then after this, a junction can also be created. What a junction is, if you want to refer this, you can go to the user guides or a reference manual over here. In the user guide, you will get to know a scenario editor. What this Now, how this lane markings are known, the lanes, and then after a junction point, and then it comes up to be a lane section. Okay, particular segments join into the links, and then it comes to a junction. This junction can also be known as a node. And then after, we need to define a route. So once I have created a road, suppose I'm creating a simple straight road. Over here, I need to define where the vehicle should move. in which lane. So over there, I will mark up a route. That is, I want my vehicle to start in this route. I will select a route and then load it in my scenario editor. Then after I will select my car. Suppose I have a car, I have a manual. Suppose I'm driving it with the IPG driver itself with the speed of 10. Okay. Uh, then it should start as per the required. You can visualize your as as guided by the Rohit. Oh yeah, yeah. Just hold on. Yeah. So this is my the middle lane on which the vehicle is moving. Similarly, while driving on your custom-made road, you have to ensure road markings as well. Then after there is, if you want to add some turns, we have an option over here that list virtual junctions as well. Okay. Then after we can also add some of the accessories. Suppose I wanted to add a stop sign. This I will add as an indication of a stop. This will automatically reflected on my movie. That is a stop sign. Similarly, you can configure your entire scenario as per your requirements. Now, once you have created your scenario, sorry, yeah, once you have created your scenario, your vehicle is ready and your manuals are set. You need to save this as a test run. Okay, what this test run means? Test run means a submission of your project file, which includes how the maneuver, how the vehicle will maneuver on what particular lane, and what is the output of your performance car. Okay, to save this, you need to save as per the name mentioned over here. That is a team ID underscore team name underscore test. Test should be the name. I have added a sample so to not to make a duplicates, but yeah, test should be a name of your vehicle while submitting a model. So you will be provided with a custom made road in which you need to maneuver your car and submit it for for a validation event. Ensure this validation event will not be evaluating your performance on the car. It is just for a submission purpose and ensuring your smooth submission. Thank you. Um, so students, I hope you will able to learn how a test run need to be saved and how a scenario editor is being loaded in your file. Um, let's start with Q&A once. Um, Sandeep, would you like to start with the first one? Hello, am I audible?
Yes, yes, you're audible. Just a
Yeah.
second.
Sandeep, just start. Okay, I will start.
Yeah,
No
yeah.
issues.
Okay, I'll
Huh.
start this. The first
The
question
first
is,
question I can. uh,
so 123 ME 0025, sorry, not that thing. Paribaha in vehicle dataset. What about engine mounting section? We haven't this one. So what we have to select? Sir, what is
For
meant by
the engine
orientation
mounting, you
XYZ
need.
degrees? See, for the orientation part, it is the way your output shaft of the motor is going to it is facing like X direction or Y direction or Z direction. The orientation is how is your motor for the E, and for engines for M and H, are positioned is known as orientation. Anyone want to add on the vehicle like engine mounting section for IBAHA section?
Hello. Yeah. Sorry, I got disconnected. Can you come once again?
So like they are asking like in the engine mount section for IBAHA what they have to use.
Okay. For if you are from eBaha team, you need to make your mass of engine as 0. You need to mention all the parameters in the powertrain section under the car file, powertrain portion. Let me show you once screen over here. Hope my screen is visible. Yeah, under the car section, if you are going with the e-Baha, then your body and chassis, your powertrain should not contain any of the engine positions. Your position should be 0, orientation should also be 0, and mass should be 0 as well. Your parameter values should be configured over here under this powertrain section, under your drive source, in the electric body, under your bodies. Here you need to mention your motor mass, and in the power supply you need to mention your battery mass. The inertia sorry, the inertia values should be added over here, and the position, that is the assembly portion, should be mentioned in the drive force 0 in electric motor section at position with reference to FRD coordinate system. Uh, I hope this is cleared.
Okay, I hope that answer is different. We are going to we are going with two-stage gear reduction gearbox. So what option we have to select from the following: manual, automatic, automatic with conversion, automatic manual transmission, continuous variable transmission, dual clutch, DVA, no gearbox.
Um, if you are going with two-stage gear reduction model, then you need to configure that in the manual section if you are having your clutch parameters. Um, in case in case if you are not having your clutch parameters, then you can maneuver them as automated manual transmission, and then and at that position you need to mention both the gearbox and their transmission ratios. Okay.
Sir, can you shortly
Uh,
explain the SKC for rear trailing arm suspension assembly or linear to DOF?
um, lean it is completely based on your geometry. If you are going with the HM, we recommend you to start with the 2DOF model. Uh, this double wishbone geometry is not supported with the HM configuration in IPG kinematics. Sandeep, would you like to add anything on this?
Like, see, linear to DOF is like your like multi-body simulation of your a suspension part. So as also it is mentioned in the guidelines, like what exactly, and also from the yesterday's section, we have shown you how this wing affects, like what is the downs and bounds, track travel, your turning radius, while at the bumps or the corners. So that's all things comes under the transitions of X, Y, TX, TY, TZs. So kindly once refer to the guidelines, it is purely mentioned. In case if you need anything else, just reach out to us. We'll give you more clarification on that thing. I couldn't able to import the general OBJ file. What could be the issues? So see, the general OBJ will be imported. There won't be any issues. If still once you check the format and the position where you are placing that, if you need any more support, just let me know. So we are using a trailing arm for the rear suspension, but there is no option for it in IPG Carmaker. So which suspension type should we select?
For the rear trailing arm, we need to understand geometry once. So please reach out to us in person for the same. Yeah. In vehicle data set, in some sets at middle. Right, God. There is a option. Okay. In vehicle data sets, in some set at middle point, right corner, there is an option called model. Okay. This model refers to the various sections. Like if you are having a custom code representing your calculations of your car or some analysis, then that particular model can be incorporated with the help of C code or MATLAB or any other language. And yeah, that can be created with the help of model options in the vehicle data set. Uh, for more information, you can refer to the programmer's guide. There you will get how to create a custom code for each particular model.
So could you please explain once again about creating the SKC file step by step?
Okay. So for this now, at very first, you need to run your analysis under the IPG kinematics. Once you will run your IPG kinematics analysis. At that point, you will be having number of files in the project folder where your kinematics dictionary is present. In that particular folder, you can find a SKC file which is having all the log values mentioning a traveling of your wheel with respect to a bump or a drop with some force analysis as well. So you need to import that into your project folder as described in the Carmaker guidelines, and rename it and load it into the section of IPG kinematics. Okay, how should we choose our own design to run in animation? Okay, for this now, you have to select your car file. Once you have created your car file, while saving up in the test run, you need to ensure that your particular car file is selected instead of any other project folder. For product example, uh, I hope it has been cleared while referring to the test run creation for section. Can you can you please share the recording of today's, as voice is not coming clear? Yes, your today's session will also be shared in short time. how to import a CAD file with color from SolidWorks to IPG Carmaker. Yeah. This you can do with the help of obj file. You need to ensure your material is loaded while creating a CAD file for each subsections, and then after you can refer to the Carmaker guidelines in which a detailed explanation has been provided. And what kind of assumption? Uh, for the HAM section, in IPG kinematics, we are not having a direct model, so it is recommended to use 2 degree or 3 degree of freedom as per your customs. We are a our doubt is how to create a traffic vehicle before ego vehicle with a predefined speed profile. Okay. For this now, if you are from a Baha, generally you used to get a ready-made model. In case if you want to create your custom file, you have to go. Just hold on, I will share my screen once. Yeah. In the parameters under the scenario editor, once you have created your particular role, you will be having a option called switch to dynamic scenarios. In the dynamic scenarios, you will be having a traffic objects, that is a ego vehicle, which refers to your own car, that is a custom made car. And then we are having a traffic objects as well. In the traffic objects, you have to select either of the vehicle, whichever you wanted to select uh, mm, to be as a traffic object. Over here, in the traffic object, you need to first add your model. Suppose I have selected one of the car from my project folders, any one, and then selected it. Now I will put their orientations, like with respect to the routes or how the offset is. Suppose I want to make it ahead or with 10 meters. So, so it has been shifted to 10 meters. Now, if you want to create a maneuver profile for this traffic objects, you have to maneuver it over here. In the maneuver section, you can read it and thoroughly refer to the user guide once. Yeah, thank you. I hope your doubt is cleared. Can you please re-explain in it for e-Baha? What exactly you want us to re-explain for e-Baha? Nityanand, can you please touch this out? Sir, I have been trying to import OBJ file with the material file, but still getting a vehicle in gray color. Uh, um, for this now, you can refer the reference manual or the user guide once thoroughly. It should be a material file with all the color codings. Yet, if you are facing an error, we recommend you not to spend much time on the same, and you can use general OBJ file provided by us. As this OBJ file is only for the aesthetic purpose of your vehicle and will not be helping you out with your car parameters. Yeah. Um, mounting. Mounting of the e-Baha powertrain you wanted to understand. Okay. Uh, I hope my screen is visible. Okay. Under this parameters for the e-Baha powertrain, you can you have to first select your powertrain as a electric model. That then after, in the general section, you need to select the number of motors you are having. Suppose you are having a single motor, then select as one. Then after, select the type like front axle, that is front wheel drive or rear wheel drive. If you are having a two electric motors, you have a front wheel plus left plus right, or rear plus left or right, or front and rear as individual file. Suppose we are going with this for one electric motor and rear. Then after, you need to add a drive source over here, that is a gearbox and a motor. You can refer my yesterday's session on this detailedly. If the gearbox is if your motor is mounted directly with the gearbox, you need to select it as no gearbox and then mention all the things over the drive line. In the electric motors, you need to mention your motor torques and efficiencies. Then after inverters, you can skip if you are not having a regenerative breakings. Then after, for the rear wheel axles, you need to make your gearbox connections as this transmission number is defined as the gear ratio which you are implementing. Efficiency of the gearbox can never be one, so ensure this uh, as per your calculations and sum of the inertia in and output. Power supply. For the power supply, you will be having your mountings of LV battery, HV battery, and their parameters. That is a capacity, voltage, state of charge, and and further similar options. Then after, coming to the control unit. Control unit simply refers to your entire powertrain control. That is a guess. In this guess, you need to mention your torque, zero and full, your battery management system. If you are not having your battery management, mark it as off. Regeneration you can configure with the same. Similarly, traction control unit, motor control unit, and battery control unit are needed to be configured. If you are still having some of the queries, personally. Thank you.
So does the two angle
Uh,
conversion in kinematics following 1 meter 1 min is equals to 60 degrees, or it is different?
uh,
Rohit, hello. Rohit, would you like to answer on this?
uh, Sorry for the disconnections. Uh, Sandeep, can you come again with the questions?
Yeah,
Uh,
yeah, I'll
can
definitely.
you try with a DAE file?
No, no,
What?
there is another query before
Okay.
that. Does the two angle
Mhm.
conversion in kinematics follow one minimum is equals to 60 degrees, or it is different?
Okay, hold on. Uh, in the IPG kinematics for what particular case you want us to refer? Sandeep, did you get the question or what this
Like basically the
thing
toe
means?
angle which we keep in the vehicle, if they wanted to replicate
Mhm.
that thing, so the like distance we are gaining in that area. So does that mean it's 60 degrees or what the degrees like for the one measurement it is? The scaling, basically they're asking. अभी आए हो? इतना लेट? अच्छा वापस
Hello, Sandeep. Let me take one query.
Yeah,
Uh,
definitely, Manoj.
yeah. Where you have asked like show the tire generation again. So I hope it is like just the generation of other two files from the tire TDX file, right? So let me share my screen once. Okay, hope it is visible. So once you have edited all your parameters according to the ATV's parameters like the BKD tires, all this radius, tire width, aspect ratio, and everything. Go to your project folder, and I hope you are clear, like from where we have to get the tire generation file, right? So it is in Carmaker, Windows, and then go to bin. It will be here, tire utility. This is an executable file, so just copy this file and then paste it in your project folder where the tire file is available. It will be available in data, tire, examples, and then it will be available in here, TDX file. So let me delete the generated files in here. I'll put this in this front folder. I'll paste this. So if you are opening like command prompt directly from the run, it is like a bit messy to type in all this uh, directory names. So what you have to do is just type cmd in this directory and then press enter. You will have this uh, directly in this thing. So you can go to notepad. This naming is according to your whatever you have named, your team ID, team name, front and rear. I have it for front and rear. You can have it separately for front and separately for rear too. So once this is done, this text can be found in here. This is outer shell. Tires. If you go scroll down to the tire dataset generator, after here you'll find this whole mapping. You just have to copy this tire utility if file, and if file in the name you have to give in your name .tdx. So this is the input file and these are all the output files. So you just have to change the namings here. can just copy this and then change your name and then come to this command prompt. You can put this here. And once that is done, let me just open the folder too so that you can see it live. So once this is done, just have to press enter. As you can see, once the executable is completed, the two extra files, this bin file and the name file, will be created, where you can select this file for your IPG Carmaker and you're good to go. Hope this clears your query. Thank you. Sandeep, you can take over.
Yeah. Thank you, Manoj, for that thing. So I guess that's done. Still, if you are having case any doubt in this exporting regarding, you can like any of one can feel free to reach out to us. We are mentioning like there are numbers we are dropping in the chat box. So if you can contact to any one of us while you are having any of the issues, okay? Any more questions further?
Yeah, teams, any more questions to ask? Um, since there are no more questions, any more questions to ask, we can conclude this session over here. Yeah, thank you. Thank you all. Thank you, Sandeep. Thank you, Sudarshan. Thank you, Manoj, for joining and delivering your technical aspects.
Thank you,
Uh,
Ligan, as well as for you also.
I hope teams will able to create their car files as of now. We have already put it our contacts in the chat box. Please reach out to us in case of any query, or you can even post it on the forum. Our IPG team will help you out on the same via forum. Yeah. Uh, thank you. Thank you all for joining.
Thank you, guys. You guys can contact us in the given uh, contact numbers so that if you have any doubts, we can connect via Google Meet and then we can clear those doubts clear. Thank you.
Which mail to use to access forum? Yeah, you must be having your Teams forum account that you need to use for the same.